6-6 inverse trig functions. We are going to go over all of these, and let's just go on to the next one. Okay, one thing I want you to remember is when we talked about an inverse function. Inverse is where you switch your x's and your y's, so f inverse would be y and x. So it only makes sense that if you're going to do that, you need to make sure you switch your domains and your ranges. So if you have an embedded inverse, for example here, what you're going to worry about is what's on the inside. This is the domain you're going to have to worry about. Same with f of x. That's the domain you need to worry about. Okay, so in here, the definition of the inverse sine function. The inverse sine function is denoted with that -1, which is the arc sine. It doesn't mean put it 1 over sine. All right, and what you need to understand is that with the inverse function, well, let's just take a look first at the graph. If you look here at this graph, this is your sine graph right here, right? It goes all the way, but what you want to remember is in order for you to have an inverse, it has to be 1-to-1. So in other words, when you do your horizontal line test, it can't cross it in two places. So what we end up doing is we end up restraining our domain to make it 1-to-1. So if we go from -pi/2 to pi/2, that makes that function 1-to-1. So that's exactly what we did here, is we just restrained the domain. So now you've got a domain of -pi/2 to pi/2 and a range of -1 to 1. So with the inverse, you're going to switch your x's and y's. So now your domain was -pi/2 to pi/2. Now it's -1 to 1, and your range is -pi/2 to pi/2. And this is important to understand because when you start looking for arc sines, you need to make sure that your value is within your domain. You'll see what I mean in the next, or in some of these examples. One thing you need to remember is that if you have the sine and the inverse sine of x, what it does is pretty much cancels it out. So that's what happened in this situation, is it canceled it out. Again, remember that we're looking at this domain, the domain of the inverse. The domain of the regular sine would be -pi/2 to pi/2, but you flip the domain, so what you really have is the range to your sine. And then here, now we're looking at, again, you've got the inverse and the sine, so you need to just make sure that you're taking the domain of sine x, which is -pi/2 to pi/2. Make sure your value fits in your domain. Okay, so we're looking at A. A. And A is the arc sine of -1/2, which equals y. So we're actually talking about the sine of -1/2. Sorry, the sine of y. The sine of y equals -1/2. What we have to consider is what is our, we're talking about y, and y is for arc sine, -pi/2 less than or equal to y less than or equal to pi/2. We've got to make sure that 1/2 is within that range. And it is. So if we draw ourselves a reference, now remember we're only dealing with from here to here, -pi/2 to pi/2. So if I know that my y value is going to be -1 and that my r is going to be 2, I've got this triangle, this is -1, and this is 2. So I want to know what angle is the sine 1/2. And if you look at your circle, it's going to be the angle of 30 degrees. And 30 degrees in the bottom is going to be -pi/6. Okay, so now let's move on to B. Okay, let's do B, and in B we've got the sine inverse of the sine of 1.2, And again, we still want to make sure that we're okay, that our value is okay. And so we want to go between negative pi over 2 is less than or equal to 1.2, which is less than or equal to pi over 2. 1.2 is within that range, so because you have the negative, the inverse, and the regular sign, your answer is going to be 1.2. All right, let's go to C. And with C, you have the cosine of the sine inverse of 2/3. And so let's take a look at first just this point. So the sine inverse of 2/3 is equal to y. Therefore, the sine of what angle is equal to 2/3. All right. So we need to remember that this is in between negative pi over 2, which is less than or equal to y, which is less than or equal to pi over 2. So let's go ahead and draw our reference triangle here. So we're talking about only in this area, and we know that the sine is going to be y. Y is 2, and then your r is 3. Oops, y is positive. That's negative 2. We want positive 2. So we want 2, and your r is 3. So we're going to go something like this, where this is 2 and this is 3. So in order to find the cosine, we need to figure out, cosine is going to be our x. We've got to figure out our x. So again, we're going x squared plus y squared equals r squared. And our x we don't know. X squared plus 4 equals 9. So our x is going to be the square root of 5. Therefore, what our answer is our cosine of y is going to be our x square root of 5 over r. Okay, now it's your turn, and I'm just going to I'm going to go ahead and pause it, and I'll put the answers on for you. Okay, this next one's pretty simple. You're just going to put it in the calculator. The only thing you need to worry about is make sure in your mode you have it set to radian. And when we put it in the calculator, you're going to press your second button so that you can get to your inverse sine. And your answer should be, on this one, negative 0.3091. All right, let's do B. Okay, now the only thing you really have to worry about are these values right here. You have to make sure that they're within range. Okay, so when we look at this next one, 1.357, okay, 1.357, that's your y value, which needs to be between -1 and 1, and it's not, therefore you're getting an error. And then finally, your C, you've got the cotangent of the sine inverse of -0.1087. Okay, so we will put in the cotangent, and so what you're really doing is you're doing 1 over the tangent of the inverse sine of -0.1087. And when you do that, you should get -9.145. Okay, now looking at the inverse cosine, again we want to make it 1-to-1. What I want you to notice is here's the graph of the cosine, and so we want to cut it off so that we can pass the horizontal line test. That's why this time they're going from 0 to pi. So if we go from 0 to pi, we have a real nice looking curve there that we can go ahead and change. And what we're going to do is now we're going to do the inverse. Oops. Now we're going to do the inverse here, and you're going to switch your domains and your ranges. So now my domain is -1 to 1, and my range is 0 to pi. Okay, let's go on to finding the exact values in problem number 3. And with problem number 3, first thing we're going to look at is the arc cosine of -√3 over 2. And so with A, we've got actually the arc cosine of negative square root of 3 over 2 is equal to y. And so we've got that the cosine of y is equal to negative square root of 3 over 2. Okay, so now if the best way to do this is to kind of look at what we're talking about here, our domain is going to be from 0, because we're talking about the arc cosine. Okay, so we're going from 0, which is less than or equal to I, which is less than or equal to pi. And we just want to make sure we're going from, let's draw our graph. So here's our graph, and we're going this time from 0 to pi. These are the angles that we're talking about. We're talking about the square root of 3 over 2, and we're doing negative, which means we're going to be in this area. So the cosine of the square root of 3 over 2 is going to be, looking at your circle, it's going to be 30 degrees, but we're talking about this 30 degrees. So in radians, we're talking about 5 pi over 6. All right, now going on to B. Okay, for B this time, we're talking about the cosine of the cosine inverse of 0.7. And so if you think about the domain here of the cosine inverse of 0.7, what you want to think about here is the cosine is, the domain is from, and the inverse is going to be from negative 1 to 1. And we've got 0.7, and it fits, therefore the answer is 0.7, because the cosine and the inverse cancel each other out. Okay, let's go to C. C, we've got the sine of the cosine of negative 1, negative 1/3. And so the first one we're going to deal with is the cosine inverse of negative 1/3. So that's going to be the cosine of what degrees is negative 1/3. And again, we're talking about 0 is less than or equal to y, which is less than or equal to pi. So if we draw our graph, we're dealing with this section, and we're doing negative 1/3, so it's going to be in this section here. So what I need to figure out is what the sine is. So I know that x is negative 1, r is 3, so I need y. So I've got x squared is 1 plus y squared equals 9. Therefore, y is going to be equal to the square root of 8, and y in this value is positive, so square root of 8 is actually 2 square root of 2. So to find the sine, all you have to do is the sine of y is going to be equal to 2 square root of 2 over your r, which is 3. All right, go ahead and pause. I'll put up the answers. Okay, this is straight up. Use your calculator. So for A, the only thing you have to make sure is make sure you're in radian. And for A, you should get 1.124. For B, again, make sure you look at, don't forget to look to make sure that these are within your values. And from here, we're going to negative 1 less than or equal to y, which is less than or equal to 1. It's in there. Here, we're going negative 1 less than or equal to y, which is less than or equal to 1. This does not fit in our domain, so you're going to get an error, which means it's not defined. And then for C, here, you're going between negative 1 and 1. So when you plug this all in, and don't forget for the cosecant, you're going to go 1 over the sine of the cosine inverse of negative 0.0349, and you should get 1.001. All right, it's your turn. Go ahead and pause, try it, and I'll put the answers up. All right, now sticking with the same thought, now look, when we look here at the tangent, we only need one part of the tangent, so why not cut it off here, because that's a nice curve. Okay, our domain is negative pi over 2 to pi over 2, and our range is negative infinity to infinity. So when we do the arc tangent, our domain is going to be negative infinity to infinity, and our range is negative pi over 2 to pi over 2. So let's go on to here, and we've got the tangent inverse on number 5. And the tangent inverse means that what we want to do is we want to go the tangent of y is equal to negative 1 over the square root of 3. All right, and with this, again, we're going between negative pi over 2 is less than or equal to y, less than or equal to pi over 2. So if we draw our graph, we only want to use this side, and since it's negative, that means we're going to be in this area. Okay, so what angle is the tangent 1 over the square root of 3? And if you look at your triangle, that would be 30 degrees, which is pi over 6, so we're going to use negative pi over 6. All right, let's go to B. Now we've got the tangent inverse of the tangent of 0.63. And we need to make sure that this is within our values. And since we're talking about the tangent of 0.63, we're going between negative pi over 2 and pi over 2, and it works. Therefore, your answer is 0.63. All right, go ahead and pause. I'll put down the answers. The only thing I want you to notice is here you're going from negative infinity to infinity because you're talking about the inverse. And before we were talking about just the regular tangent. All right, let's go on to this next thing. Here's where it tells you how to do it, what your domains are. Okay, and here's looking at the sine, the cosine, and the inverse tangent. It just gives you an overview of all of it. And then here's where you're going to start talking cotangent, secant, and cosecant. And so if you think about the cotangent, it's just like doing what you had before. The best way to do it is to graph them and then look at what you've got. Here's your homework. Good luck. Don't do the inverse tangents.